Hello friends, welcome to my channel. So here we are going to look at problem 973, key closest points to origin. This is a very good example for using data structure to solve problems. So here we are going to use a heap and maintain its length kept at the given key. So actually we can also make a class and override the down less than method. So for this you can refer to the video for problem 3275. So here we are focusing on solve this problem itself. So here given an array called points with points to be xi and yi represented by a two-element list. So also we are given an integer key. We want to find the key closest point to the origin. So the distance here is L2 distance. Notice that in problem 3275, the distance is L1 distance. We may return the answer in any order. The answer is guaranteed to be unique except the order that is in it. So here are two examples. So here, so k is 1, right? So you see here is 1 square plus 3 square is 10, and this is 4, right? 4 plus 4, 8. Square root 8 is less than square root 10, so we get this point. So here we want to find those points, right? Similarly, you can see example 2. So it's a typical heap application. So what we are going to do is this. So we initialize a result variable, right? And so we actually don't need this result variable. So we can directly later replace the heap, return the heap. So we initialize a heap and then we do a for loop to scan the points. So xy in enumerate points. What we want to push into the heap is the negative L2 distance or negative L2 distance square. So this way we will when the heap attains length k plus 1, then we're going to pop one element. So this way we can maintain the smallest negative L2 distances, which corresponds to nearest points to the origin, right? That's the push in this heap. Then what we are going to push into actually is this. So x square plus y square. So here notice that this is not the L2 distance, but it's a square. So the same thing, we can achieve the same effect, right? And here I also want to input the points. So this way, once I finish the traversal, I can directly return the component corresponding to the point of the heap, right? So then we can do if I is greater than or equal to k. So in this case, we have at more than k elements, we should pop that. So we do heap q, heap pop. So in this way, actually we're done. So now what we want to return is so atom. So we want to return the last element corresponding to a tuple. It's a point for atom in heap. So notice that after we do the for loop, the heap will maintain a length k, right? So this is what we want to return. Let's do a quick check. Heap q, heap pop. Well, we need to write the object. Yeah, it passes one example. Let's also check the second example to give you a feeling. So if you cannot easily grasp the main idea, so I would suggest that you walk through this example, right? So let's first submit, and then for completeness, we can make a walkthrough for the second example. So the point, let's see, 3, 3, and its negative L2 distance square will be what? 3 square plus 3 square is negative 18, right? If put negative sign. So this is what's in the heap, right? So now let's push another one. So this is the 5 and negative 1. 5, negative 1. The 5 square is 25. Negative 1 square is 1, so we get 26. So we get negative 26. So actually, this will correspond to the top element in the heap. Let me move this one here, right? So now let's put, so here k equals 2, right? Let's put push this guy. So 2, negative 2, 4 into the heap. So negative 2 square is 4. So this 4 square is 16. So it's negative 20, right? So negative 20, once you push this one, so you're going to pop the heap top element. So you're going to pop out this one. So what you return will be the 2 points corresponding to 3, 3, and negative 2 and 4, right? So this is the point. But notice that the heap order is not fixed. So you can also return negative 2, 4, and then 3, 3. So this simple example actually demonstrates the way, and also demonstrate why we put negative L2 distance square here. So with that said, I guess that's it for the solution for this current problem.